All right, good morning, everybody. Thank you for taking time out of your day to join me. Again, we are doing upgrading to Siemens TIA Portal from S5 and S7 Classic. So, just some background information on who I am. I'm coming up on my 3-year anniversary with C&E Advanced Technologies. Before that, I spent 18 and a half years with another Siemens distributor and integrator. And then even before that, I spent 2 years working directly for Siemens. I do have my certification as from Profibus. I also have my Profinet certification, and Siemens has certified me in PLCs, HMIs, and networking. So basically, I've been around for a while. So what we want to talk about today, I want to do an overview of the whole upgrading process, why we need to do an upgrade. We're going to talk about project considerations. We want to do a review of the hardware, and we want to talk about the software conversion. So, the overview, basically, why are we all here? Why do we want a modern automation system? Well, hopefully, modern systems can help us increase productivity, reduce production costs, increase utilization, and then give us in compliance with newer regulations, namely security and safety. We're going to hopefully improve our product quality and process control, and then have greater flexibility in production, and then support future integration and expansion. Anytime that you're dealing with an older legacy product and you want to add on to it, it's always a very cumbersome and difficult situation. So, many of you know, some of you don't, but S5 components have been discontinued since 2003 and are no longer manufactured. So way back in October 1st of 2002, Siemens sent out a letter basically saying the S5 days are numbered. So what happens when Siemens announces a product is going to be matured is they give a year for normal delivery, and then 10 years after that they will do support, but the only way you're going to get product is through as spare parts. So anything that's been repaired or anything that gets scrounged up, they basically, in those green years, they are not making new product anymore. And then after those 10 years, they are going to discontinue completely. Basically, not getting support for that product at all. So that is all in the past now. So one other thing that we're having a problem with is the software. Okay, many people say, hey, well, I can find these PLC products on eBay or whatever, the hardware, but the software is also going to become an issue. With S5, the software is not compatible with the latest version of Windows. Basically, S5 stopped at version 7.23, and it will run on Windows XP, Service Pack 1, 2, or 3. It will not run on any modern Windows operating software. Now, I do know that there are third-party software packages out there that say they can work with S5 in a modern Windows operating system, but I do not normally work with those products, so I can't speak to that. Another issue that we're having is laptops and desktops are no longer shipping with serial ports. So some of you may remember this really famous cable. This is the RS-232 to TTY converter cable. This is the cable you needed to talk to any S5 processor out of the box. All right, so I know some people are trying to use a USB to serial adapter, but I've had hit or miss luck with those kinds of products, quite frankly. So back in the day when I used to work with S5 all the time, I used to keep an old laptop that had a serial port, and that was the only thing that I used that laptop for, was for S5. So as far as the S7 300 and 400 systems, all right, phasing out of the S7 300, 400 system is not scheduled before 2020. All right, so and even when they do announce that they're going to phase those out, the components for both of those will be available for another 10 years after that. So if you got an S7 300, 400 system, you're going to be okay for a good long while. Okay. Now, some of you might be thinking, okay, well, I have the S7 300/400, but I like the Portal environment. I want to program in Portal. The good news is the TIA Portal software will work for newer versions of the S7 300 and 400 systems. Basically anything manufactured after October 1st of 2007. Now, I know what you're thinking too. You're thinking, hey, well, that's great, but how do I know when my PLC was manufactured? There's no born-on date on it. There's nothing on the front cover that would indicate whether or not I could use it with Portal. Well, luckily for us, Siemens gives us a tool for that. Okay, and the tool is this readiness check for TIA Portal, for totally integrated automation portal. All right, this is a free download from Siemens. If you do a Google search for readiness check totally integrated automation portal, you should be able to find the link to download the software for it. And it's a really quick download. It's a small program. But once you get into it, basically it's really nice because you can read in your entire project from S7 Classic. You can import it in as an Excel file or a CSV file, or you can enter the order numbers in manually. So here, for an example, I entered in an S7 315 processor. This part number is for the very first S7 315 that they ever made. So when I go in here and I manually input that in, what it's going to come back is, the result is going to say that this product is not supported by TIA Portal. So I would not be able to use this processor in a Portal project. However, if I come back in and I input the part number for the very latest, greatest S7 315 processor, it's going to come back and it's saying, hey, I'm good to go. I could program this CPU using TIA Portal. So that's the best way to check whether or not your S7 300/400 system can handle TIA Portal. So, project considerations. There's lots of things that we want to think about before you even begin the migration process. All right, so we want to think about what parts of the plant should be migrated first. And there's lots of things that we're going to have to think about for that. So we're also going to think about which components are affected. All right, is this PLC that we're going to replace, is it standalone or is it part of a complex plant configuration? All right, are we going to have communications with third-party systems? Is there existing special hardware and software that we need to think about? All right. How about migration time? Is this machine running 24/7? Is there a way where we can increase production so that we can offset downtimes when we do the upgrade? Can we shift production to another machine? We also then want to think about fallback strategies. We want to allow migration back to a previous configuration if we have to. All right. Okay. We can take this migration and we can do it in steps. Obviously, there's going to be a point of no return, but hopefully, when you get to that point, you're going to be sure that your upgrade is going to work with no problems. So we're going to do that with testing. We want to test the software as much as possible. I know shadow testing is really popular, where you have your existing S5 CPU running in parallel with the new S7 1500 processor. We want to minimize risk, obviously. We want to accurately capture the actual plant. We want to know exactly how this machine is running right now. There's nothing worse than doing an upgrade and then you end up debating, hey, you know, did this machine used to do this before? Is this a problem with the upgrade, or was it always doing this? So we want to take that out of the equation. We want to plan each phase, obviously. We want to decide whether or not we're going to do a gradual or separate migration. All right, and as far as partial and complete migrations, obviously, if we lived in an ideal world, we could take down our machine for 2 weeks and we can do an upgrade and come back out of that 2-week outage and we'll be good to go 100%. But we don't live in a perfect world. Oftentimes I deal with customers who they may take a 12-hour outage every other week, and then they're down for 5 days, 2 times a year. So those are the things that you need to think about on whether or not you can do a complete migration or a partial migration. So here in this picture, on the left-hand side, we've got our older S5 CPU, and we were doing Profibus to some older ET200U and ET200B remote I/O modules. So if we want to do a partial migration, what we could do is we can drop in an S7 1500, and then there is a device called an IEPB link. So it's an Profinet to Profibus converter, basically, and it allows us to leave his remote I/O alone. So maybe we come in one outage, and you replace the CPU, and then, I mean, when we come into a long outage, we can replace the CPU, and then we can gradually replace his remote I/O in those smaller outages, and then we get to a completed product. Okay. Now, something I want to point out here, this shows us completely switching over to Profinet. So we get into this debate a lot, Profibus or Profinet. Profibus is a perfectly viable product. It's going to be around for a long, long time. Okay. It's going to be around for a long, long time. So, in fact, you can get some S7 1500 processors that talk Profibus. They have Profibus built in. You can purchase extra additional communication modules that would also talk Profibus. So I don't want you to get the impression that Profibus is going away either. All right. But this is just showing you an example of upgrading your I/O to Profinet as well. Okay. So options are all over the place. We want to look at the complexity of the control system, so this control solution. Is it a single or multiple network controllers? Is there a connection to a third-party system? Is there monitoring equipment that we need to think about? A lot of the mills that I work with, they have really advanced data acquisition software that they use that's vital to the process. So we need to figure out how we're going to integrate to those equipment as well. And then if there's any special function, positioning, PID, high-speed counters, those are all the things that you need to take into account. And then also which bus systems are being utilized. Is it central or distributed I/O? And then we also have to look at the communication protocols. So some of you guys may know these terms, some of you guys may not. We're going to review them, but we all have SYNC H1 and SYNC L1 and SYNC L2, those great old-fashioned terms. All right, so those are the things that we need to think about. We also need to think about how much downtime are we allowed, okay? How much downtime are we allowed? What kind of budget are we looking at? Maybe this year we only have money to do the processor, and then we have to wait another year to do the remote I/O. Those are the kind of financial things you need to think about. And then you also have production flexibility, and then upgrades and expansions planned for the future. All right, there's no reason to upgrade an S5 processor if you're already planning on replacing that machine in 3 or 4 years, right? So what we want to talk about next is the hardware. All right, the hardware to go from step 5 to TIA Portal. So back in the old S5 days, we had our 100 and S5, the 195U processors. Those were the low-end processors. Those basically are going to get replaced with an S7 1200 processor. When you get to the mid-range and the high-end processors, the 115Us, the 135 and 155Us, those would typically be replaced with an S7 1500. So, luckily for us, first we want to talk about this too. Going from step 7 to TIA Portal. Step 7, you had those old S7 200 processors. Those clearly are going to get replaced with an S7 1200, and then the S7 300s and 400s are going to go to an S7 1500. All right. So, fortunately for us, Siemens does a really good job of cross-referencing the older S5 processors with the newer S7 Portal processors. So here's just, I don't want to make this a death by PowerPoint presentation. So this slide basically just talks about, is an example of how Siemens has cross-referenced older processors and newer processors. So here on the left-hand side, you've got some of the S5 115U processors, and then you can see the equivalent processors in Portal. All right, and those cross references exist, and I'll talk about where you can find all these cross references here towards the end here. So something else that's helpful for us is I/O adapters. What they allow for is you can take your old S5 front connectors and use an I/O adapter to get it up to an S715 I/O card without having to do a lot of rewiring. So this picture, what this picture shows is you've got your old S5 connector, the front connector in your old S5 I/O modules, and the adapter is a printed circuit board that that connector gets plugged into, and then it's pre-wired to a front connector for an S7 1500. So this is a huge time saver when we're talking about doing upgrades, okay? And then what you can do is you can do a double mounted rail, mounting rail, and it hides those front connectors underneath of it. So it's a nice option if you want to save some time with your wiring. Some other things that we need to think about is the different communication protocols. So first thing I want to talk about is SYNIC H1. SYNIC H1 was the communication protocol that covers layers 2 to 7 of the ISO OSI reference model. So that's basically Ethernet. All right, and back in the old S5 days, you had 2 different flavors of that processor, of that communication processor. You had the CP1430 TF card, which basically you dealt in MAC addresses. The way you set up communications was you based it off of MAC addresses. And then you had the CP1430 TCP card, and that worked off of TCP addressing. So typically any of the older machines use the TF cards, and the later machines would use the TCP card. All right, the good news is it's just Ethernet. So what this picture shows is that we can easily integrate an S7 1500 with an S5 processor over an Ethernet network. All right, so you've got your Siemens modern Siemens HMI panel and your S7 1500 processors on top. Those would be talking Profinet, and Profinet is just a protocol that talks on Ethernet. All right. And then you have your older S5 modules down below that are talking SYNIC H1. All right, and this this item number 3 here is just it can be either a managed or unmanaged switch. And then item number 4 here, that's just an AUI to RJ45 adapter. So we can integrate an S5 with an S7 on Ethernet, and it's not a problem. SYNIC L2. Some of you guys may know this, some of you guys may not, but SYNIC L2 was the bus system that networks the S5 with programmers and other control systems. Profibus compatible devices from various manufacturers can be connected to this bus system. Basically, SYNIC L2 was Profibus before they started calling it Profibus. So the next thing we want to talk about is SYNIC L1. Now, SYNIC L1 was the predecessor to SYNIC L2. SYNIC L1 was used to communicate to drives and remote I/O, namely the ET100U. All right. The big issue that we have here with SYNIC L1 is that direct connections with SYNIC L1 to an S7 1200 or 1500 is not possible. There is no way we can have an S7 1200 or an S7 1500 talk SYNIC L1. So if you have ET100U remote I/O devices, we're not going to be able to get an S7 to talk to it. If you have a drive that was talking SYNIC L1, we're not going to be able to get an S7 processor to talk to it. So There's a couple of things that you can do in this situation. You can actually change an ET100U to an ET200U form factor. And ET200U is Profibus. All right, and we already talked that we can, an S7 1500 can talk Profibus with no problems. All right, and the way we do that is we change the interface module. All right, so this is the older ET100U remote I/O head, and then this is an ET200U remote I/O head. And you just need to swap out this module. The backplane is the same, the I/O is the same between an ET100U and an ET200U. All right, and the cabling may be able to be reused as well. The specs for the cabling for ET100U is the same specs as Profibus. Now, whether or not your existing system used the correct cable, that is something you need to verify and check. All right, and if you're in doubt, run new cable. All right, now, is this the most ideal situation? No, because you're replacing, in order to do this, in order to get your I/O up on Profibus, you're having to buy a product that isn't manufactured anymore. So I always hate to tell a customer, hey, buy a piece of material that we already know is out of date, is already a mature product. But again, if you have a situation where you're trying to do an upgrade in parts and pieces, a partial upgrade, this is a solution that's available to you. It's not the best solution, but it is a solution. All right, so there is one gotcha when you do this. All right, the old ET100U and ET200U I/O cards, all right, they actually made a 4-point output card, a 4-point output card. Okay, so the addressing gets a little bit tricky when we go to an S7 processor. So in this example here, I've got an 8-point digital input, an 8-point digital input followed by a 4-point digital output, a 4-point digital output, and then another 8, and then an 8-point digital output. In S5, the way we could address these I/O points, we could take that first digital input and address it as I10.0 to 10.7. The second digital input would be I11.0 to I11.7. And then the first digital output would be Q10.0 to 10.3, and then the second digital output would be 10.4 to output 10.7. You can actually assign 1/2 of a byte to one card and another 1/2 of the byte to another card. And then obviously this 8-point digital output is going to have a whole byte to itself, so that's Q11.0 to Q11.7. However, when we go to S7, we are not allowed, we're not able to address those cards the same way. So the digital inputs are not a problem. We can do I10.0 to I10.7 and then I11.0 to I11.7. But this first digital output, we can still address it as Q10.0 to Q10.3. However, that second digital output, the second 4-point digital output card, we can't address it as Q10.4 to Q10.7 anymore. The S7 software doesn't allow us to start addressing a card in the middle of a byte. So basically we have to assign a whole different byte to it. So this guy goes to something like Q50.0 to Q50.3. All right, and then that digital output can still be, the last digital output can still be Q11.0 to Q11.7. All right. What this means is for these 4 digital outputs, you're going to have to go in and adjust your programming. You're going to have to adjust your addressing to reflect that. So just be aware of that situation. All right. Now, what do we do about a variable frequency drive? Some of these older Siemens variable frequency drives could only communicate, could communicate via SYNC L1, but not SYNC L2. All right. So we're kind of stuck here. We're kind of at an impasse. Well, one solution could be is that we upgrade the VFDs before the CPU. All right. So that's a perfectly good option. However, I've had some customers who say, hey, you know, this drive, we don't want to mess with it. It's fine. We got plenty of spare parts, but we want to upgrade our processor. So One thing that we can do is we can leave the existing S5 system in and use that as a communication bridge between the old VFDs and the new S7 1200 and 1500. All right, so how do we do this? How's the best way to do this? All right, well, first off, we're going to take out almost all the logic out of the S5 CPU, except for a few move commands. And those move commands are going to basically take inputs from the S7 1500 and then write it as outputs via Cynic L1 to the drives. And then feedback would work the opposite way. So I always think a picture is worth 1,000 words, and we're going to get to it, but I forgot. The big thing that's going to help us here is there's a card that's called the IM308C interface module. This is a Profibus module for S5. And if I could vote and name the most valuable card in an S5 rack, it'd be this guy. This guy has a unique ability to be both a Profibus slave and a master at the same time. Okay, so you can have this inside of an S5 processor, and it could be controlling its own remote I/O. But also, I could be talking to this over Profibus from an S7 1500. All right, so it can be both a Profibus master and Profibus slave at the same time. Not every Profibus device has this capability, so this is a really nice capability. So what I would do is if we had an S7 1500 and an old Siemens VFD, and we wanted to leave that VFD in for whatever reason, maybe it's too expensive to upgrade, we just don't want to do it yet, what we can do is we can have that S7 1500 talking Profibus to an S5 that has that IM308C card. And then out of that S5, we use it as a communication bridge and talk Cynic L1 to the drives. So again, this is a partial migration. Is this the most ideal situation? No. But again, we often don't have the money or the time to do a complete upgrade. All right. So I have done this a few times in my past life, and it's worked pretty well. All right. So now we want to talk about the software. All right. So just a quick review. Some of you guys may know this, some of you guys may not. But back in the old S5 days, we had LAD for ladder logic, CSF for control system flowchart, and STL for statement list. In S7, we've got ladder, LAD. We've got function block diagram, FBD. And function block diagram is the exact same thing as control system flowchart in S5. They just renamed it. And then, of course, we have our old friend STL statement list in the S7 1500. Okay. Now, statement list is not supported in the S7 1200. All right. It is not supported in the S7 1200. Now, what we have is SCL is now standard in an S7 1200 and a 1500. SCL stands for Structured Control Language. All right. So those are just some things to keep in mind. Those of you who have Graph 5, Graph still is available in S7, so that won't be a problem. All right. Going from S5 blocks to S7 blocks. All right. Well, obviously, we still have organizational blocks. OB1 still does the same thing it used to do in S5. It still does the logic as fast as it can. Now, something that's interesting here is you can see here we've got function blocks and extended function blocks. That's what FX is. So function blocks, extended function blocks, program blocks, and system blocks all get converted into functions in S7. All right, functions are very powerful. So basically, functions can do everything function blocks, extended functions, program blocks, and sequence blocks used to do in S5. In S5, we had those data blocks and extended data blocks. Well, we still have data blocks in S7, but they're a lot better now, and we'll talk about that here in just a second. And then, yes, in S7, we still have function blocks, but they are I don't want you to think about function blocks in S7 as the same as function blocks in S5. Function blocks in an S7 is far more powerful and just a lot better off to work with. But in general, function blocks in S5 will get converted to functions in S7. Okay? So, data blocks. If you guys remember, in old step 5, data blocks used word addressing. You can actually use data word 0 and data word 1 and data word 2 in your program, and you wouldn't be overriding anything. All right? Big change that happens in S7 is that data blocks uses byte addressing now. All right, so we cannot use data word 0, data word 1, data word 2. We would be overriding bytes every time we do that. So S7 also allows us to structure, access, and document data in data blocks in ways that we couldn't have done in S5. All right, in ways that we couldn't have done in S5. If you guys remember, in S5, there was no reason to assign data words in your assignment list, right? Because you couldn't tell, hey, which data block this data word was assigned to. In step 7, you can actually document the bits, bytes, words, and double words used in an S7 data block. And it really helps with the troubleshooting now. So this is just a kind of a summary now, since, and don't forget, in S5, we used true 16-bit words here. And in S7, we're doing byte addressing now. So in S5, when you would use data left commands, all right, basically in S7, those are data block byte commands, and those are going to be referencing the even bytes. When you do a data right in S5, a DR, it would be a data block byte command, but we're going to reference the odd number of bytes. And of course, you can see here data word 0, data word 1, data word 2. As I said, now we're doing byte addressing, so that's going to be data block words 0, 2, 4, and 6. So those are the changes that happen for data blocks. Internal memory has changed a little bit. We used to have flags for S5. Now we have M's for S7. M's for memory in S7. They work pretty much the same way. We just got a whole lot more of it. Now, I want to talk about something. There was an unwritten rule in S5, and some of you guys may know about this, some of you guys may not. But there was an unwritten rule in S5, and that unwritten rule was that basically said flags from F200.0 to F255.7 were used as scratch flags in function blocks. Basically, they were used as temporary data, basically, scratch flags. Well, the cool thing is now in S7, we have temporary local data now. What makes that cool? The cool thing is now we can document our scratch flags in each function block, or not in each function block, but in each function. So that's really nice that we can do that. All right? So, now for some bad news. I got some bad news. So the bad news is if we want to upgrade our software from Step 5 to TIA Portal, it's going to be a two-step process. First process is we've got to upgrade the Step 5 program to Step 7 version 5.x. So 5.x is what we call S7 Classic nowadays. So we have to get it up to S7 Classic. Then the next step is to migrate your Step 7 version 5 project into TIA Portal. So it's a two-step process. All right. So we're going to talk about step 1. How do we get our S5 into an S7 version 5.x project? Well, that converter tool is supplied and installed automatically when you get Step 7 version 5.x. So you may have seen this icon and wondered what it was. This is the converter tool to go from S5 to S7. All right. So there's a couple of files that we need to do this conversion. All right. One thing we definitely need is the st.s5d file. You guys remember that's the Step 5 program. This is all DOS-based back then, right? So we only could name things up to 8 characters, but that S5 program always had to end in st.s5d. So we actually only could name your programs with 6 characters. Then we also need either the xr.ini file, which is the cross-reference file, or the z0.seq file. All right, my preference is I want the z0.seq file because that's the assignment list. That's where most of your documentation is going to live. So you got those 2 files. All right. Oh, and one thing important to note, the program is converted as is with no enhancements. Okay, so a lot of times there's some really nice, cool things about S7 now, right? We already talked about it a little bit. You can document your data words and your data block elements a lot easier. You don't have to worry about scratch flags as much. You can document those scratch flags individually per block. All right. The problem is this converter program is just going to convert the program as is. It's not going to take advantage of some of those newer, nice features. Those are things that you'd have to do on your own. So the program converts the program as is with no enhancements. So when you come in here into the converter, it's going to look something like this. You can go in here and you can set it up. You can point to your st.s5d file and your z0.seq file. And what it's going to do, it's going to, first off, renumber everything. And I know that's kind of annoying, but it's kind of unavoidable since you're taking functions, extended functions, programs, and SB blocks, and they're all going to become FCs. All right, so it's going to renumber your blocks for you. But basically, you run this conversion, and when it's completed, you're going to get some errors and you can get some warnings. All right, and don't be surprised if you have a lot of errors here. We're going to talk about why that is, but don't be surprised. Don't worry. There are just going to be errors that happens. All right, and we'll talk about how to fix that here in just a second. All right, so then you get the option to be able to print some things. So this picture I snagged just has block assignment and STL source files and S5 assignment list selected. Things I always like to print is the block assignment. All right, that's like your converter guide. That's really good for your maintenance guys who are used to saying, hey, every time we have a problem with this part of the machine, I always go to program block 50. Well, he's got to know that program 50 now is FC75 in the S7 now, or whatever. All right, so that block assignments are pretty important. All right, and then I always like to print out the error list. And you want to go through this error list pretty good. All right. So please note, there's some things you got to keep in mind. There are a number of special instructions, system, and organizational blocks, data types that do not conform to the International Electrotechnical Commission, IEC. So IEC creates some programming standards, all right? And S5 didn't conform to all of them, or maybe it conformed to them back in the 80s when they came out, but now it doesn't. So some of these special instructions no longer exist in S7 version 5.x or TIA Portal, because Step 7 and TIA Portal both conform to the IEC standards. So that's one of the reasons why you get a lot of errors. These program constructs are commented out, and then you get the error messages. It's up to you to rework your program until all those errors go away or are corrected. The good news is there are some legacy blocks for Step 5 timers and counters. Those old Step 5 timers and counters technically do not conform to the IEC standard, but what Siemens has done is they've incorporated that with Step 7 version 5.x and also in TIA Portal. Those legacy blocks still exist. And then some Step 5 code is just no longer going to be needed in Step 7 and can be deleted. All right. I remember distinctly back, I had an S5 and it was talking to a third-party HMI. And at the time, we were required to create a send block, a receive block, and you had to use the synchron blocks. to get it to talk to that third-party HMI. Nowadays, some of those HMIs have drivers, and they just go in and get the information that they need, and you don't have to do anything in the PLC at all. S5s, you had to do a lot more work back then, back in those days. Upgrading to TIA Portal requires a consistent Step 7 version 5.x project. So how do you get a consistent project? Well, if you open up Semantic Manager, you can go down and drill down to your blocks folder in S7 Classic. And you can right-click on it, and there's an option there called Check Block Consistency. Check Block Consistency will open up a pop-up, and you can basically check your consistency there, and you get no errors. Then you're ready to go on to the second step. All right, and the second step is getting your Step 7 project, or Step 7 version 5.x program into TIA Portal. Generally, you can migrate all of your programs to TIA Portal. However, there's still some special commands and blocks that may need to be adjusted after migration. And also something I want to point out, back in S7, you could have, there is such a thing called multi-projects. We're not going to be able to migrate an entire multi-project as a whole. You have to take those individual projects to Portal. All right, and then one final note, or another note here is Step 7 version 5.x and TIA Portal need to be installed in your laptop. When Portal does the conversion, it looks at something, it looks for something in Step 7 version 5.x to do the conversion. The good news is the required tool for upgrading is embedded with TIA Portal. Some of you guys who are used to Portal now may not have even seen this little option here, but in Portal, underneath where you normally would open existing project or create a new project, you do have the option to migrate a project. All right. When you do the migration, you get the option on whether or not you want to include the hardware configuration. All right. Why would you include the hardware configuration? When would you not? Typically, if you're going from S5 and you're going to go into Portal, you're going to have to create a new hardware configuration anyway, so there's no hardware configuration upgrade. I would check this box if I had an S7 300 or 400 and it was made after October 1st, 2007, and I wasn't going to replace the hardware. I was going to keep that hardware configuration. I just want to upgrade the software. Then you want to check that box. So, just a summary. I've been talking for a while. We did an overview, talked about project considerations, talked about the hardware conversion and the software conversion. So some of you guys might be thinking, man, this was really good, but I want to know more. That's good. So some documents out there that you can find. There's a guide for migrating Semantic S5 projects to Semantic S7 1500 and TIA Portal. Simple Google search will find that. There's also a really nice Step 7 from S5 to S7 converter manual. This is the converter manual that will go into painful details on how to get from S5 to S7 Classic, S7 version 5.x. Okay, and it goes into a lot of detail on making that happen. And then there's also a really nice document about the interface module adapter. And then for those of you who have S7 300s and 400s and want to go to a 1500 or TIA Portal or TIA Portal, there's a document for that as well. So these are all really nice documents. So my final thoughts: get help if you need it. All right, there are integrators that we work with that have experience doing upgrades. They have the Step 7 version 5.x software. So get help if you need it. Some other things I always want people to think about: plan every step. Think about your risk versus your reward. Are you taking too big of a chunk in this part of the upgrade? Maybe you should break it into smaller steps. You want to test as much as possible. Shadow testing is always really popular, where you have both processors running together and you can port over information and you can see how the new processor is going to react. And then you probably want to think about fallback plans. And then you always want to think, because you're always going to have that point of no return. But when you get to that point of no return, you always want to make sure that you're ready to go. I can't imagine a worse feeling that you go to the point of no return, past the point of no return, and then only to realize a large chunk of your program is not going to work, and you're going to have to rewrite a lot of it. Those are the kinds of days where you cry yourself to sleep at night and you question the decisions you made in life. So don't let that happen to you. Okay. So at that point, if you have any questions, we can talk about them.
Yeah, thanks, Howard. A lot of great stuff there. We do have a question. It came in from James Fawson about 17 minutes into the webinar, if that helps you with any timing. It is, would it be unthinkable to replace an older low-end processor with a newer high-end processor?
Would it be unthinkable? No, it is not. So I think I know where he's going with that. I've had situations where a customer may have had 5 smaller S5 processors, and he said, hey, instead of replacing it with 5 smaller S7 processors, how about one big S7 processor and control them all? Yeah, no, that's not unthinkable. The only thing to think about in a situation like what I talked about is, if you take a machine that had, or a process that had 5 individual processors and you turned it into one big processor, now anytime you take that one big processor down, all 5 of those stations are going to go dead. Whereas in the old days, you could take one down for maintenance, the other 4 still work. So if that answers his question, I hope that answers his question. If not, holler at us again. That's
right. That was the only question. I'll give just a few moments here to see. Sometimes it takes a little bit of time, for a typed question to kind of come into that panel. So we'll be at just a few seconds. We do have a follow-up. With that being said, with that being the case, you could provide an additional redundant processor for backup, correct?
Yeah, with the S7-1500, the redundancy is still coming out. I think it just came out, but yeah, you can have redundancy. You can have a redundant system. I don't know if they have released that yet. I think they may have just released that.
Right. I do know true redundancy is a little different than it's not just having 2 PLCs, and I don't know if the thought there is one old and one new, or one waiting. And me being a mixed motion guy, sometimes we would have 2 drives ready with a contactor bypass or an automatic switchover. That's far more convoluted with a PLC.
Yeah, what I'm thinking about when he says, "Hey, one on standby," I'm talking about like a hot backup system where when one fails, you automatically switch over to the next one. I know that's why they've been hanging on to the S7 300 and 400 processors for a while.
Right.
So, yeah.
I did get an okay thanks, so I think that did answer the question, and I haven't seen any other new ones come in, so I think we're going to wrap this up. Howard, thanks again. Thanks to all of you for joining. We'll get this recording posted up and a link sent out to you very shortly. Hopefully we see you next month.
All right. Thank you, everybody.